Dear viewers, welcome back to School of Civil Engineering. This is Hedaetullah with another new video of CSI SAP 2000 tutorial series. So in your previous 6 lecture, I have just shown you that how we'll analyze this and find out shear force and bending moment diagram for different types of beam frame. And today I will work with a different types of frame, and already you have seen that in thumbnails that which types of frame frame we are working. So let's start, and before starting I'm just requesting you, if you new to our channel and also if you didn't subscribe to our channel, then must subscribe to our channel and also press the bell icon. So first of all, I'll open our software. Here I'm using SAP 2000, and also almost 97 video of CSI ETAPs, the tutorial series are available in our channel. So that playlist is also given in description. You can learn about ETAPs from A to Z. Okay, so first of all I have to click here new model. So here new model, after that I'll just select here grid only. Okay, I'll select here grid only. So for that, and before that we have to change our unit. So from here I'm just using LB feet or key feet. Okay, key feet Fahrenheit. So this is our unit section. Now when it's done, now I'll just select grid only, and from here they have two types, cylindrical and Cartesian. So I'll use that option, and after that what will be our grid section. So in our in y direction our grid line will be 4, sorry, x direction it will be 4, and our grid line in y direction, that will be 1, because will not work in y direction also. So in z direction that will be 4. Okay, that will be also 4. So it's done. Now here we'll change that grid spacing later. So I'm simply clicking OK. Okay, so here is our 3D view, and if I click our YZ, so this is our 2D view, right? So this is our 2D view. Now now I'll just right click, then grid data. So the global, then modify. Okay, after that from here I'll just give the distance. So here every distance is feet, and I'll just change that option spacing. Okay, and the spacing from A to B, that will be 24 feet here given. I'll just consider that is okay 10 feet. Then I'm taking a random value. Okay, I'm just showing you that how will work with that frame. So I'm just giving here suppose 9. Okay, and in y direction, okay, take it 12 feet, 12 feet, 12 feet, that's okay, right? And here we can also take add another grid line. Okay, so I think it will be required, so add, and here I'll just give here consider that is 11. Okay, so now simply click here OK and OK. So when it's done, sorry, again I have to check that. Coordinates, I'll just add here 1, and I'll just give her 11, then enter. Okay, so when it's done in x direction, now I'll just simply click OK, then OK. Now it's okay. So here it's okay. Now we have to draw our frame. Okay, so simply I'll take a line from here, and this is FSCE. Actually this is not fact which types of frame we are using, because we'll not consider the load of that frame. We'll analyze our model with respect to the external load. Okay, So simply here the section are given, and this is a state frame. Okay, so and the moment release continuous. So from here, from that point to that point, I'll just go here, and from here I'll just come here, and from here I'll come here. So actually this is our, I'll escape. So this is our mainframe, shape of our mainframe, right? So here I'll select that to assign support, assign join, then restraint, and here this is the hinge, and here roller. Okay, it's done, right? Otherwise we can use here fixed. I hope it will be great. And here we'll use hinge, apply, then okay. So when it's done, now we have to assign load here actually. Okay, so how will assign load here actually? So to assign load here, actually where we will assign load? So here I will assign a, I mean in that frame I will assign a point load. Okay, and here I will assign a uniformly varying load, and here I will assign a uniformly distributed load. Okay, so for that I will just click here to show our grid system, click here, then show local axis, then apply, then okay, because our that frame, so here we're seeing the local axis, but in 3D it will be better. So I'll select here, and from here I'll just again go here, then show local axis, then apply. Okay, so sorry, we'll show local axis not in joint. I will again apply. I will use here local axis in frame. So here it's done, right? Then okay, and for that I'll just remove it. I'll remove it, then apply. Okay, so it's done. Now we'll apply load as per the direction in that axis. Okay, so first of all I will apply load on here. I will apply a point load middle of that frame. So I have selected that. After that I will just, and I will apply in that direction. Okay, with respect to that that green line. Okay, so from here I have selected that, then assign, then frame load. Okay, then click here point load, and from here there are two options actually. So for that types of frame we will use the relative distance option. Okay, I mean at how much distance you want to apply your load in that frame, right? So I just want to apply that load at middle. So what I have to do actually, so here also I can give it 0.5. okay, our relative distance will be 0.5. actually what is the relative distance actually? Suppose your that frame, your this frame length is 10 feet. Okay, your that frame length is 10 feet and you want to apply load, it's middle. So after, that's why if you consider from that point, okay, this is the point, if you try to consider from that point, okay, and every time from the lower point you have to consider. So if we want to apply load from that point, right, from that point, so what will be the distance of middle? 5 of 10, then we have to divide it that 5 by 10, then we'll get our relative distance. So I hope you have understand. So I'll just apply load here, suppose 2 keep. Okay, I will apply load here 2 keep, and I'll just give it 0 0 and 0. Okay, so when it's done, and the most important thing is from here we have to select which types of load we are applying. We are applying dead load, and from here coordinate system. Okay, coordinate system. In coordinate system, which type, as per which direction we want to apply our load, that is local axis, okay, and there have three line, red, green, and the rest direction. So the red array is 1, the load type 2 is green, and 3 is that color, okay, I mean that one. So what we'll do actually, and so our load are in direction 2, so I'll simply select direction 2 here, but we are seeing that our that direction are in outside of our frame. So what I'll do, but I want to apply load on inside, so what I'll do, I'll just simply give a minus value, okay, I'll give a minus value, then it's okay. Now I'll apply, I'll click apply, so simply I'll click apply. Just see here, or to keep load have applied it, okay, that's easy, very easy. So I'll just again close that, and here, I mean in that frame, I mean that full frame, I will assign, okay, in that full frame I will assign uniformly varying load. So how will assign, I will again go assign, then frame load, then distributed load, okay. Okay, now here this is distributed load, and that load should be applied in here again the opposite direction of local axis 2. So from here local and axis 2, and that value will be in minus. So if we apply load on it, okay, uniformly load, then simply you can give here, but our load is not uniform, our load is varying. So from relative distance when 0, then our load will be suppose 3 kip, okay, and when our relative distance is 1, then our load is 0, clear. So I'll just give 0 here, I'll just give 0 here, I'll just give 0, okay. Actually this is the process to apply load, okay, this is the process to apply load, and our that point, I mean the down point will be first point, and that point will be the second point, okay. So when our relative distance 0, then it's 3, and when our relative distance 1, then it's 0, I mean at this point it's 3 and that point is 0. So simply, and it should be minus, okay, it should be minus, right. So when it's here, then I'll simply click here apply. Just see here, our load is okay now, okay. So here we have applied that our load successfully, very clear. So when it's done, now we'll apply load here, a distributed load, we'll apply distributed load. So simply I'll select that frame, okay, I'll select that frame, and here as we will apply distributed load, and we'll see again the direction are this is the direction, and this is also green, okay. So what we'll do actually here, we'll simply select that one, okay, we'll select that option, and here I'll just give 1 kip perfect, and the direction should be again minus, okay. So now it's, I'll just give it 0, I'll just give it 0, okay, and simply click apply. So see here, here is our load. So we have successfully applied it our load, where how much load we required actually, right. So I'll just simply close that when it's okay. Now before analyze, we have to do something, go define and go load pattern, and from here the self weight multiplier will use 0, because we will not use self weight of that frame, we will just apply we'll modify, then okay. So we'll apply that load, okay, we'll apply, I mean we'll analyze that frame with respect to the provided load, right. And here they have a point load, and that load is available here. If we see in load, it's here, there's a point load 2, but it's not showing because of other loads. So this load is available here. Now simply what we'll do, we'll go for analysis. When it's done, now I'll go for analysis, but before that we have to save that. So we'll not analyze for model, we'll only analyze for dead load, and I'll click run, and before that I have to save. So I'll just give it frame analysis 2. Okay, FA2. So again I have analysis frame. Just see here, here is the deflection form of our frame, and here if we want to see the reaction, okay, that's reaction. So what we'll do actually, simply go display, then show frame stress, then joint, and from here for dead load arrows, then apply. So where is the load actually? Okay, here is the load actually here. Just see here, here is the load, right, and this is the upper direction load, and this is the horizontal load, and this is the vertical, and this is the horizontal load. Okay, so when it's done, I'll just click close, and after that we'll see moment diagram, right, shear force and bending moment diagram. For that here, then frame cable, and for dead load, and it should be for force, and for axial load we can see that for axial load, so here axial load is also available, right. And now I'll just go here, shear to apply. So here is the shear force diagram. Okay, this is the shear force diagram. And okay, so here is your shear force diagram. And if you want to find out moment diagram, so here you can see the moment diagram in that side, so that we can understand. M33 apply. So that is the moment diagram. Okay, so just see here, it's showing us the moment diagram here. Okay, and we can see that in YZ direction. Just see here, here is the moment diagram of that frame. And also you can get that data from tabular form, it's up to you. So actually if you want to see the data in, just if we take mouse here, then we'll see our shear force or bending moment diagram. So actually this is the way to find out, okay, this is the way to find out our shear force and bending moment diagram from a frame. So I hope it's okay. So in next tutorial I'll just show you that how we'll analyze a truss or different types of truss by using CSI SAP 2000. So thank you very much. Still stay connected till next video, and if you think that video is helpful for you, then please subscribe us and also press the bell icon so that you get every update ever first.